Tell me, students, if my voice is clear to you. Okay. Namaskar, Ada, Sat Sri Akal. How are you, students? I hope that all of you are doing very good in your studies. So, in this lecture, what we are going to learn, till now we have completed three major, I will say, sectors of optics. Okay, we have first lecture we have seen about reflection from what? Plane mirror. Second part we have seen about reflection from spherical mirror. Third part we have seen about refraction. We have started refraction. In this lecture also, majorly we are going to see refraction from glass lab we are studying. We are going to continue that little bit portion is left from there, and then we will be moving into spherical surfaces. Why we study spherical surfaces, what will be happening, what are the results, what are the derivations, all these things we are going to see in the spherical surfaces. And actually, one thing, if I will tell you, spherical surface becomes important because it is the actual derivation for lens. Okay, spherical surface is the point from where we derive for lens, and lens is the most important thing. Okay, lens is the majority portion of this chapter, so that is what we are going to understand. Okay, so let's I will quickly again take you where I have left you in the last lecture. Okay, I have told you about when there is a glass lab, how much normal shift will be coming. If there is a glass lab, how much normal shift will be coming. We have seen if this is an object and a ray diagram will be somewhat like this. This is the normal, this should be the normal ray, but it will bend towards the normal. Again, it will be reaching here. This should be the normal ray, but this time it will bend away from the normal. And this ray, when you will subtend, it is passing from this point. This point is called as what? Image. And this shift that is coming between the object and the image was written as T, that was thickness 1 divided by N of surrounding divided by N of slab. This was the formula, important formula that we have seen, and how this was coming, that also we have understood in complete depth. Clear? Now let's move further. Now we will be watching in these cases what was happening. If you have calculated this scenario, what was happening, both the sides were the same medium. That means the observer, the object, and the observer. Here you was the observer. Both are in the same medium. But let's suppose this kind of case is not given. Let's see here also, object is in air and observer is also in air. But let's suppose the condition is given like this. Again the shift you have to calculate. Again there will be some normal shift. But this time what is the small change that I have did? Here object I have kept in some medium N1, and the image, or sorry, the observer is kept in some medium N3. In these kind of cases, what we used to do, that is what I am going to calculate. How will be calculating this? How will be calculating this, that how much the shift will be coming, total shift after how many, if there are, let's suppose, n number of mediums I have inserted. Okay, then what will be happening? All these things we are going to understand. So let's start from the basics only. From the basics, if I will ask you a simple question, tell me one simple answer. One simple question answer, tell me that if I will ask you, tell me what is the formula of apparent depth. Can you tell me what is the formula of apparent depth? Apparent depth means is equals to what? Real depth divided by n of incident divided by n of refraction. Correct? This was what we have written for apparent depth. So let's again I am taking you there only. So first reflection will be occurring from this first surface, and the image will be forming somewhere here. Fine. So this will be called as what? Apparent depth. D dash also it can be represented. So if I have to write just for this first surface, how much I will be writing? I will be writing the distance, actual distance. What is the actual distance? T1 divided by n incident. Incident medium is n1 and refractive medium is n2. So what you can write for d dash? D dash can be written as T1 into n2 divided by n1. Any doubt? Clear? Simply you have written d dash is equals to n2 T1 divided by n1. Correct? Now come to the second refraction. Let's see what will be happening in the second refraction. Now let's suppose it is going in away. It depends. Now it will be, if it is going from denser to rarer medium, it will be going away from the normal, and if it is rarer to denser medium, so nothing is given about that value. So let's assume anything, and from this surface let's try to calculate where the image will be forming. Let's suppose here the image is forming, it is going like this away from the, and let's suppose here is the image is forming. I don't know, I don't have any values, so let's suppose here is a final image is forming. Here is a final image is forming, and after that of course the rays will be reaching to the eyes, and that's it. That is a two reflection cases. Okay, so if I have to write this distance, the new apparent depth d dash, actually it will be calculated from here. So how I will be writing d double dash? D double dash will be written. Now can you say this image will be now behaving like object for the second phenomena? This is what we are going to do. So tell me, what is the actual depth you are going to tell? This complete distance, how much you have written? You have calculated here, that is equals to n2 by n1 into t1, correct? And plus, can you say this thickness t2? That is the total real depth you are going to write. Is it clear? From the surface everything is calculated. So I hope that this will be clear. Divided by n of incident medium. Tell me, what is the incident medium here? Incident medium, students, it is nothing but n2 divided by refractive medium. What is the refractive medium? Refractive medium is what? N3. Refractive medium is N3. Acha, one more thing I will tell you to remember this result like this way. Remember this result as T1 divided by N1 divided by N2. N of incidence, or also remember this as T1 N of incident medium divided by N of refractive. Don't remember anything in terms of N1 and N2. I will tell you. Always remember in terms of which one is incident medium and which one is refractive medium. In this way, always try to remember. Or if you don't want to remember in this way also, always remember this formulas in terms of from to to. From where it is coming to where it is going. But still, I will say that always remember this is incident and refractive medium. Okay. So now let's calculate for this one. Let's see how much it is becoming. यहाँ पे LCM ले लो. What you will be getting here? N2. Remove it. N2 T1 plus N1 T2 divided by what you will be saying, and here it is a multiplication of N3, and here multiply N1 into N2, correct? Now further write this result. How you will be writing? Do what? N3, let it as it is, and here what will be remaining? What will be doing? If we are taking this LCM from this first term, splitting, I am basically doing splitting. N2 will be get cancelled. What will be remaining? T1 by N1 plus here what will be saying? T2 divided by N1 cancel. Here it will be T2 by N2. So here this normal shift total will be coming N3, that is the medium in which your eyes are present, multiplied by N1 divided by N1 plus T2 divided by N2. Just simply what I am doing. If I want to calculate some in general things, because all the time I am not going to perform this much times of apparent depth and doing these kind of things. I have to solve it very fast. So I have to create a generalized thing. So here it is sufficient result to create me generalized thing. Let's suppose here not only T2, T3 and N3, T4, N4, this kind of number of mediums are there. What I will be doing? I will be simply writing N of what? Where my eyes are present or where the observer is present. Then I will simply taking the ratio of thickness divided by refractive index, thickness divided by refractive index plus, and just keep them adding. This is what the general thing that we can derive from here. And anyways, the formula is also there to tell you. Here this was the completely derivation for d double dash. See, if let's suppose this kind of n number of slabs are given, then how will we write it? D n naught. N naught is what? N naught is the medium in which your eyes are present or the observer is present. Then you just have to take the ratio T1 by N1, T2 by N2, T3 by N3 and just keep them adding up till the n number of slabs, and that's it. That is what your final result will be coming. Clear? Easy? For example, there is a question, and the same kind of PYQ was one PYQ was there in JEE Mains exam. Okay, so try to solve this question. What is there? Here is an observer kept, and he is in air. Okay, and here is a ball. Here at the base, it is kept a ball. The question is asking you find the location of the image found by the object placed at the bottom of the container. You have to find or locate the position of image. You have to locate the position of image. Let's see. Let's try. What is the position of the image? What we know in this, when object and image are both are in different mediums, I know the result is just multiply n naught, that is the refractive index of the observer, n naught, and actually it is going to be 1. Then just simply do t1 by n1 plus t2 by n2 plus t3 by n3. How many mediums are there? Only 3 mediums, that's it. N naught will be equals to 1. T1, how much thickness is there? 15 divided by refractive index 1.5 plus T2, 20 divided by refractive index, that is 2, plus T3, that is 24 divided by 1.2. Correct? Here it will become how much? It will become 10 times, correct? 10 plus, here it will again become 10 plus, here it will become 20. That means what is the position of the image that is coming? 10, 10, 20, that means 40 centimeter. That is equals to 40 centimeter. Is it clear? 40 centimeter. So this way you will be easily solving all the questions of this kind of variety. 40 centimeter will be the answer. Clear? Now let's come to the next and the last portion of slab. That is about lateral shift. Now what is this lateral shift? We have seen everything about normal shift, but now what is this term lateral shift? क्या होता है lateral shift? See, firstly I will be proving you some things, and then I will be telling you how much we can go into the quantitative analysis. Firstly, always do the qualitative analysis of anything, कि समझो how this thing is actually working also, and then go into the formulas and rest of the things and the problems. Okay, firstly let's understand what is lateral shift. Okay, see, what I basically, this is what it is given here. It will be very clear to you looking that there is a slab, okay, and here it is an incident ray, and finally 2 times of reflection will be happening, and then again the ray will be going and emerging. No problem, this is the basic thing that I know. That is basically in this complete phenomena, in this complete process, 2 basic reflections are happening. Correct? Now let's write the 2 basic reflections and try to understand what actually I am trying to tell you. Firstly, let's prove yourself. I will ask you, please write Snell's law at the first surface. Write Snell's law at the first surface. क्या लिखोगे Snell's law? Write n1 sine of I is equals to n2 sine of r1. Correct? This angle will be what? r1. Clear? And it is going from rarer to denser medium. That's why I am taking towards normal. And then this ray will be coming. Let's suppose this ray this angle will become r2 some angle, and then again it will be emergent angle. Now apply Snell's law at this surface. When you will be applying Snell's law at this surface, how you will be writing? You will be writing, and इसको पहले proper लिख लो. Write it properly. Okay. N1 is what? Air. So write it 1 into sine of I is equals to n2 is nothing but given as n into sine of r1. Now let's write the Snell's law here. How will you be writing Snell's law here? You will be writing n into sine of r2 is equals to air is there. That means I will directly write sine of e. So I can write what? Sine of e is equals to n times of sine of r2. This is equation 1, this is equation 2. Now notice one thing in this complete construction. What you have to notice that I am telling you. Check karo, can I say both these are parallel and both are normals? That means I can say this line and this line are going to be parallel. And you know the property of straight lines, that I can say simply here r1 is equals to r2. Angle r1 is equals to r2. Yes or no? If angle r1 is equal to r2, can you say sine of r1 and sine of r2 are also equal? Correct? So I can say sine of r1 and sine of r2 are also equal. That means I can say n sine of r1 and n sine of r2 are also equal. Yes or no? Correct? So what I can say from equation 1 and 2 directly, that sine of I is equals to sine of e. Sine of I is equals to sine of e. That's why I can also say that angle of incidence is equals to angle of emergence. This is a very important line that I am telling you, that angle of incidence is equals to angle of emergence. Due to that, what will be happening? I am saying that from this vertical line, this angle is I. So I can say from this vertical line, this angle is also what? This E is nothing but equals to I. So if both these angles are equal from this vertical, can I say this line that was proceeding further, if I will take this completely, and this line, can you say they are nothing but what? Parallel. अरे समझ आया नहीं आया? Can't I say that they are going to be parallel because this angle is also I, this angle is also the end we have proved that it is also I. So I can say from the same vertical line, two lines are parallel. They are not the same line, but they are actually parallel. The final emergent ray that is coming, it is equals to the actual origin. It is parallel to the actual incident ray. Clear? So now what is lateral shift? Now let's come to the term. What is lateral shift? Lateral shift says that, okay, fine, two rays are parallel, actual normal incident ray and the final emergent ray both are parallel, but there is some shift. There is some shift, and that shift is called as what? Lateral shift. That shift is called as what? Lateral shift. Okay. So that is what now we are interested in calculating. What is the lateral shift? Firstly, we have did the qualitative analysis. We have seen all the overviews that what actually it is defined, why it is defined, reasoning we have seen. Now let's come to the quantitative analysis, that how we are going to get the formula. Okay, let's see. Let's derive the formula. You have to construct little bit construction you have to do, and little bit geometry applied. See what I am asking you, write all the things. Let's firstly do the namkaran. This point, let's suppose A. This point is, let's suppose B. This point is already defined as C, and define this point as D. Okay, define this point as T. Firstly, tell me what you will be writing cos of R in triangle ABC. In triangle ABC, write cos of R. What you will be writing? Check the angles properly. Shairi. After the class, sure I will. अभी अचानक से दिमाग में नहीं आएगा ना यार, ठीक है, पहले पढ़ लेते हैं, उसके बाद शायरी करेंगे. See, focus on this triangle ABC. In this triangle, if I will ask you, अच्छा ठीक है, पहले पढ़ लेते हैं. There is some important topic, then we will be having some shairis and everything. Okay, don't worry. ठीक है यार, पढ़ो. देखो, in triangle ABC, it is a right angle triangle. If I'll ask you, tell me, can you find the distance AC? Because why? This is a process that yeah. Okay, I will do, sure, but let me teach as of now. Important. सब मोह माया है. ठीक है, then from tomorrow there is no biology class. Only I will be taking at the place of biology classes. Biology is also some moh maya yaar. Why there is no need to study biology? Don't you feel that biology is not a subject to study? I feel so. You see, physics is so interesting. You see, you visualize everything. Okay. Hi, hello, Bhanu Pratap. So Bhanu will tell everyone that we should study biology or not. But anyways, without physics you cannot do anything. So firstly, let's focus here. अरे शायरी अभी दिमाग में नहीं आया है यार, क्या कर रहे हो? See, define cos of R. Cos of R, because why I am trying to do this, I want this length A to C. I want this length A to C. Okay. So define cos of R into this triangle. Cos of R, if I will ask what is the formula of cos theta? Cos theta is defined as base upon hypotenuse. So define the base. What is the base that you will be writing? AB divided by the hypotenuse. What you will be writing? Hypotenuse AC. So if I'll ask you, tell me what is AC, how you will be defining? AC is equals to, tell me what you will be writing for this AB length. AB length is nothing but the thickness of the slab that is already given the value here, that you will be writing as T divided by the AC. AC you will be already written, and here cos of R. So you can also write this as sec of R. You can also write this distance as sec of R. Now I will ask you, basically you have to reach here. At the end, the motto is to calculate this lateral shift CD distance. Okay. So now if I'll ask you, can you tell me what is this angle? What is this angle? If this angle is I, this complete total is going to be I, and this portion, little portion, is R. So if I'll ask you, can you tell me what is this angle? This angle will be nothing but I minus of R. This angle will be nothing but I minus R. So now define sine of I minus R in the triangle, in the right angle triangle. I hope that this right angle triangle is clear to you. I will erase this one. The name's also gone. This is point D. I hope that this right angle triangle is clearly visible to you, and in that right angle triangle I am asking you about sine of I minus of R. कैसे define करोगे? What is sine of theta? It is perpendicular upon hypotenuse. What is the perpendicular? You will say CD divided by hypotenuse. Hypotenuse is what? AC. That is why I have already asked you to calculate AC, because that was going to come into use there. Now CD is what actually we want to calculate. That is what our lateral shift. I am representing it as LS, lateral shift. It is equals to, simply I can say, AC multiplied by sine of I minus R. What is AC? AC, just you have calculated, it is equals to T sec of R into sine of I minus R. This is what the formula of lateral shift you have to remember. Not a very standard result, but still it is what it is. So this is the standard result, final result that you have to remember. Lateral shift is equal to T sec of R into sine of I minus R. T sec of R sine of I minus R. This is the final result that you'll be getting. Let's have a basic question on this. Now it depends on you. If you want to, because in the initial questions, apply this complete derivation by yourself. Try karo, nothing special, just apply geometry in the two triangles. Basically we are doing what, and final end goal is what? To calculate this S value. So basic trigonometry we are applying, there is nothing special, but still you should be doing by yourself and then applying the formula. Let's see, we are going to directly apply the formula because we have already seen it. So the question is, find the lateral shift. Okay, lateral shift you have to calculate basically, and this angle of incidence is given as 60 degree. What is the formula of lateral shift, students? Just you have written, it is equals to T sec of R into sine of I minus R. What is the thickness that you will be writing? 10 sec of R. Now what is the value of R? It is not given, so you have to calculate, and multiplied by sine of I minus R, that means 60 minus of R. R actually we have to calculate. Without calculating R, you cannot proceed this question. Okay. So calculate R. Apply Snell's law. What is Snell's law? A lot of times now we have applied N1 into sine of 60. Tell me what is sine of 60? It is nothing but root under 3 by 2 is equals to root 3 into sine of R. Cancel. R will be equals to 30 degree. R will be equals to 30 degree. So put 30 here. This will be also 30, this will be also 30. 10 into sec of 30. Sec of 30 is what? What is cos of 30? Cos of 30 is root under 3 by 2. Root under 3 by 2, that means sec of 30 will become 2 by root under 3 multiplied by sine of 30. Sine of 30 is nothing but half. Sine of 30 will be half, correct now? So this half will get cancelled. Finally, your lateral shift will be coming, that is equals to 10 divided by root 3 meter. That means the shift. And what is the lateral shift? In the diagram also you can represent, this was the original incident ray, this is the final emergent ray, and this shift that is coming in these two lines, it is equals to 10 divided by root 3. Clear? Is it clear now? So this is the way how you will be calculating. We have discussed both about in complete depth about lateral shift, also about normal shift also. Okay, these are the two kind of shift that you will be observing in slabs in generally. And from where these two things are derived, always remember the basics. We have firstly seen the apparent depth concept, how you calculate the apparent depth, then apparent shift also we have discussed there also. So all these things are connected, and even the next topic, that is about prism, that is also completely connected with all these concepts. So everything is related to each other. You cannot skip any single thing also. If you are skipping any single thing, then you will be having pain in all the concepts. So before starting prism, we have to understand the phenomena of TIR. Okay, all of you have seen learned about TIR. What is TIR? So let's understand what is TIR. How many? General relativity. Let's start the topic TIR. Okay, so for the first thing is critical angle. What is critical angle? Before starting TIR, you have to understand what is critical angle. Okay, critical angle, what is see, basic TIR happens when you are going from denser medium to rarer medium. When you are going from denser medium to rarer medium, the phenomena that you will be observing, what is happening actually, if I will tell you, when you are going from denser medium to rarer medium, this kind of phenomena will be occurring. This is the original path of the incident ray, and then it is the bending that you will be having. Going from denser to rarer medium, what I've told you, bending is always away from the normal. Bending is away from the normal, that is R. So if I'll ask you, this will be R, simple, no problem. But what will happen, let's suppose if I have, let's suppose this is the source and I have taken one more incident angle. Let's suppose I have increased this angle, let's suppose I dash, some name is I dash. I have increased the angle of incidence first, then due to that what will be happening, this angle of refraction will also be increasing. This will become R2. This will become R2. But I can say here which angle is greater. I can say R is greater than I. Here R is greater than I. And here what I will say, that R2 is again greater than the I dash. That means if I am increasing the angle of incidence, angle of reflection is more increasing. Angle of reflection is more increasing. Let's suppose I want to further increase this angle. I want to further increase this angle. So I will reach to a point. I will reach to a point where this angle of reflection will be keep increasing at some angle. It will become perpendicular. It will become 90 degree. And this is the critical point for TIR also. Thank you so much, sir, for answering. Now see, I was telling you about critical angle. So at the moment when this angle of refraction becomes 90 degree, that means perpendicular from the normal, at that point this is the critical point. And after that, even if you have increased the angle of incidence about 0.001 also, no, it will not perform reflection. Reflection will fail here and it will start performing reflection, and that reflection is called as total internal reflection. What are the two important conditions? Anyways, we are going to understand. For a moment, just understand what is critical angle. This is the critical point, and the angle of incidence at which angle of refraction becomes 90 degree, that angle is called as critical angle. That means the angle of incidence at which angle of reflection becomes 90 degree, that angle of incidence is represented as what? Critical angle. This angle of incidence, I will say it is equals to C, correct? So if I have to define, and I have to find the formula, qualitative analysis you have to do, just do what? Apply Snell's law. From a lot of time we are knowing about Snell's law. Kya karoge? This is the point where you have to apply Snell's law. Write Ni sin I, Ni you will write Nd into sine of I. At the place of angle of incidence, now I will be writing critical angle is equals to Nr, refractive medium, that is the rarer medium, Nr represented, into sine of R. And I will say sine of R is equals to 90. That means this value sine of 90 is equals to 1. From where I will get the formula of sine C is equal to N of rarer medium divided by N of denser medium. Very important result, always remember, because it is going to be applied when we will be calculating about TIR. We will be understanding about TIR, at that time it will be helping. So definition also I have told you. This is the formula that you have to remember. Sine of C is equal to N of rarer medium divided by N of denser medium. Clear? Now let's understand what is TIR. Critical angle, till critical angle it was clear. Now let's understand the effect of TIR and why actually refraction fails. What actually happens so that reflection got failure? Why actually it got failed? Let's understand that also. So what I was telling you, I am keep increasing this angle of incidence at every time, and I have attained a critical point where this angle of refraction becomes 90 degree. Correct? So if I will write again the Snell's law here, what will be? I will writing the Snell's law. I will write N of denser medium into sine of I is equals to 1 or N of rarer medium. Let's take it R into sine of R. Correct? N of rarer medium into sine of R. So just understand here. Now what will be happening? Can you say at critical angle, if I am talking about this critical angle, can you say sine of R, it's already achieved its maxima? What is the maximum value of sine theta? 1. And can you say it is already standing at its maximum value? Now the moment you increase this angle of incidence by a small fraction, can you say this complete sine of I have to be increased? Because sine is what? Increasing function. So if this sine of I have been increasing, can I say, and these are the constants. These are the constants. That means in the left hand side, if you are increasing any value, on the right hand side also it is mandatory for the value to be increased. Otherwise it will fail. So what will happen? You have already reached the maxima, and now the moment you will increase this, it will not be able to increase because it is already achieved its maxima. And that's why we will say that Snell's law fails. after critical angle, if you are performing any increasing the angle of incidence, Snell's law will be happening. What? Snell's law will fail. So what will happen when Snell's law fails? See, here it is, with the diagram it is represented. Here it is already achieved its maxima, and even after that you have increased. Even after that you have increased this blue ray. This blue ray is representing what? Angle of incidence is greater than critical angle. Critical angle, it will perform till critical angle, it is fine. But the moment you are increasing from critical angle, it will remove all the reflections and it will simply perform reflection. What it will perform? Reflection. What is the law of reflection? If this complete angle is I, this complete angle of reflection will be R. Angle of incidence is equal to angle of reflection. This is called as total internal reflection. Everything from the formula of deviation. Deviation will also follow the same thing. Deviation formula was what? In the reflection cases, it was 2 pi minus 2i. So same formula will be valid here. Now no reflection will be happening, and not the single formula will also be applicable. All the things that will be applying is for reflection portion. So what are the, basically, if I will ask you that tell me the conditions of TIR, first basic condition that you have to quote, that light should be going from denser to rarer medium. This is the first and the foremost important condition that you have to satisfy. Second condition that you have to satisfy, important condition, that angle of incidence should be greater than C. Angle of incidence should be greater than C. And what is the C? C is equals to critical angle. It is equals to critical angle. Formula also you know, sine of C is equals to n of rarer medium divided by n of denser medium. This is the basic meaning of TIR. Is it clear? Now let's understand the complete concept. The complete theory is also available for you, so that you can read it out in your board exam. If you're writing by this much diagram and everything, you'll be getting the complete marks. Okay. Lots of applications are also given for TIR from the NCERT. You can read out there. Optical fiber, very important application. Mirage formation, all these applications are available in your notebooks, NCERT books, so textbook. So you can read out from there. Here will be see some numerical here. Try to apply the formula here so that you can get the answer. See what is the question is saying. Find deviation when a ray traveling from denser medium to rarer medium is incident at an angle of 45 degree at the interface as shown. Okay. Anyways, we are studying about total internal reflection. That means obviously it is going to perform some kind of reflection TIR. But still, let's see. This is the surface that you have. Okay. Let's check what is our critical angle. Let's see what is our critical angle. Sine of C is equals to n of reflected medium or rarer medium divided by n of denser medium. Sine of C can be written as, what is the rarer medium? 1 divided by denser medium 2. That means what I can say about critical angle. Critical angle, that means can I say it is equals to 30 degree. And how much the angle of incidence is? Even it is going from denser to rarer medium, and this angle of incidence is also greater than the critical angle. So can I say for my TIR both the conditions are satisfied? Are yes or no? For TIR both the conditions are satisfied. What are the two conditions? Going from denser to rarer, first one, and second one is the angle of incidence should be greater than the critical angle, and both the conditions are clear here. So if I have to calculate how much the deviation, that means what will be happening now? I can say there is no reflection is going to happen, and it is the point where it is going to perform total internal reflection, TIR. And if it is going to perform TIR, simply it is going to reflect in the same medium. This angle will also be equals to 45. And for reflections, what is the formula that we know for deviation? Deviation is equals to pi minus of 2i. Pi minus 2 into I. I is how much? 45. That means 180 minus of 90. It is equals to 90 degree will be the answer. Clear? And sense of rotation will be what? This is the normal ray that is going, and this is the sense of rotation. What you will say, this is going in clockwise direction. This will be the complete answer that you will be quoting out here. Clear? Fine. Now let's see some important curves, very important curves that are present here. When it is moving from denser medium to rarer medium, how you will be writing deviation? Deviation you will be writing as R minus of I, because I have to plot a curve. If I will tell you deviation versus I have to plot a curve. So if I will be plotting this curve, how I will be writing R? How will be writing R? Apply Snell's law. You remember how Snell's law you applied at that condition? You have written what? Ni sin I is equals to Nr sin of R. So if you have to write R, how you can write R? R you can write, and if it is going from denser to rarer medium, you will be writing what? N denser divided by N rarer, and here it is what? R you have to write into sine of I. This is sine of R. That means R, if you have to write, you will be writing what? Sine inverse of this complete term ND divided by NR into sine of I. This is what you will be writing. So now substitute this. You will be writing deviation is equals to sine inverse N of denser medium divided by N of refractive medium sine of I minus of I. This is the equation that you will be having. And what is a plot? What is the curve that you have to plot? You have to plot a curve between deviation between I, here also I, and here also I in the inside sine inverse. So it is very complicated kind of curve. But when you will be putting this curve comes like this, because there is some points at I is equal to 0, how much deviation is there, and at I is equal to C, how much deviation is there. Just put the values and you will have 2 points. Just match those 2 points, you will have a curve till it is equals to critical angle. Can you tell me what will be happening after critical angle? After critical angle, what will be happening? Just after the critical angle, what happens? Actually reflection fails. That means this complete reflection or the relation that is present, that will be failing. So after reflection, what will be the result that will be valid? After reflection, it is simply what? Reflection. So I will be writing it as what? It is equals to pi minus of 2i. So I can say it is a kind of straight line. What I can say, y is equals to c minus of m. Matlab slope is negative. I can say slope is equals to minus of 2. That means this kind of curve will be coming decreasing slope. This will be the complete curve of deviation versus I. Important curve, remember it. Okay, with this relations also, try to remember this. It will be very helpful for you. Maybe it can be asked directly in your 4 options will be given, and they will ask you tell me which one is the correct option. Okay, so there it will be very helpful for you. See, these are the critical points also mentioned here. So remember it with the critical points. At what angle, how much the value is going to be. Clear? Now the next, this is a question, but actually it is a concept of area of illumination. Okay, very small concept of area of illumination. What is there? From the diagram itself I will be telling. Let's suppose here is a bucket of water kept just under your eyes. Okay, and a light source is present into the water at the center, just under your eyes. Everything should be under your eyes. Here it is also, here is your eye. That is very beautifully diagram it is shown here. Okay, see, for you we used to design this much of hard PPTs. It takes a lot of times also. And here it is a light bulb. Kahan gaya bhai? Here it is a light bulb, and light bulb is glowing. So the question will be always asking you, tell me the area of illumination. Now what is this term area of illumination? See, firstly imagine what is the scenario. Just under your eyes there is some light source that is glowing. Okay, so that light source will not be coming in one direction. So light source will be coming in all these kind of directions. In 3D, if you imagine, this will be coming in, this is the light source, light is coming in this direction also, this direction also, towards you, towards me also, in all the 3D directions. So the net area through which light is coming out, that area is called as what? Area of illumination. So there can be one more general query. Sir, why it is only why not the complete area is covered? Why not the complete area? Because after some angle, because what is happening, let's understand. Here the angle of incidence is small, but as soon as you are moving away, can you say angle of incidence is increasing? And if angle of incidence is increasing, can you say angle of reflection is more increasing? If angle of reflection is more increasing, you will attain some angle where this will become critical angle, and angle of reflection will become 90 degree. And after that, just you have moved little bit ahead from there, actually light ray will not be coming out of the surface, because you are moving from denser to rarer and you have increased from the critical angle. Both conditions are satisfied and it will perform TR. That means lights after this point is not going to be out of the surface, it will be remaining inside the surface. And if it is remaining inside the surface, it will not be looking like a glowing part. Only glowing part will be calculated by this way. So let's see what is the value. Now let's come to the qualitative analysis. कैसे calculate करेंगे? let's understand कौन सा color ले ले भाई. See, first I read the question. A light source is submerged. Okay, what are the values given? A fluid of refractive index root 2, refractive index root 2, at a depth of 1 meter. Depth of 1 meter is present. From the surface, observer is looking into the fluid just above. Find the area of the fluid through the light will be seen as a. You have to tell me what is this area of the fluid that you have taken here. See, area you have to calculate. Firstly, calculate the radius. I will be calculating the radius. For this is the distance that I will be telling you that it is the radius. And let's suppose this is the height that is given equals to 1 meter. See, now firstly calculate the critical angle. At what will be the critical angle? Critical angle will be equals to n of rarer medium divided by n of denser medium. Rarer medium is air 1, denser medium is root 2. Denser medium is root 2. That means C will be written is equals to 45 degree. Okay. See, the here I will say this angle is C. This is 45 degree. Now, if this line and parallel, that means this angle and this angle are equal. That means this will also become 45. Now define tan of 45 degree in this triangle. In which triangle? This that I am marking here. This is the right angle triangle. Tan of 45, perpendicular upon base. Perpendicular is R, base is what? H. That means R, I will say what? Tan of 45 is already 1, H is also equals to 1. That means R is equals to 1. That means area of illumination will become A is equals to how much? It will become pi R square. Pi into 1 square, that means pi meter square. This will be the answer. This is the area of illumination that you will be having. Clear? Simple? Very good. Now let's come to the prism case. If you are so confident in refraction, prism is also a complete application of refraction of Snell's law only. I will prove that. Just understand how we are going to proceed. Okay. See. Firstly, I think that all of you have watched Prism in your college or somewhere. Prism is what? The bare minimum requirement of prism that two surfaces should be at some angle. Okay, two surfaces minimum that it should be bent at some angle, and it is made up of glass so that light can be passed from there. So prism is a concept that applies passes through two inclined plane surfaces of a medium. That is what I have told you, that there will be mandatory two inclined surface, and it will have some refractive index n. Okay, some important terms if I will tell you. This point is called as A. This angle, this is called as angle of prism. This is the only unique thing that you will be watching. Angle of prism is given. Okay, and what are the, if I will tell you about the ray diagram, basic, again the same ray diagram. Draw the two normals. This is the first normal, this is the second normal, because two phenomena, two reflections will be occurring here. Now let's see what will be happening. See, this is the original incident ray, but what will be happening? You are going from rarer to denser medium. Of course, a glass prism will be denser medium. So you will be bending towards the normal or away from the normal. You will be bending towards the normal. This angle, let's suppose I am saying I. So this angle will become what? This angle, because always it is calculated from the normal. This will be called as R1. Fine. Now this is coming here on the surface 2. This is the normal. This angle will be now behaving like angle of incidence. Let's name this as R2. And now this should be the normal path along which it is moving, and I can say it is going from denser to rarer medium. That means along this is the normal path. It should bend towards the normal or away from the normal? Away from the normal. So I will say this angle will be bent away from the normal, and this is called as E. If I will be talking about the deviation, what will be the deviation here? Who is greater? I will say simply this one is the deviation. This one is what? Deviation 1. How I will be writing deviation 1? Deviation 1 will be simply written as I minus of R1, and here this is the normal ray, and here it is bent. Again deviation 2. Deviation 2 is written as E minus of R2. This is the basic structure of this complete angle. If you understand this much, no, you understand about complete prism. There is nothing that you cannot solve. I'm literally telling you all the things that in this chapter that I am going to tell you from this much only. If you are very much confident in these things that we have already did, it is not a new thing that we are going to see. We have already did all these things, and if you understand this much prism, you are done. Okay, let's prove it also. Let's see. Some minimum deviation cases will be coming. That is what only you have to understand. And all these things will be derived from here only. There is nothing new that the derivation is. Already I have told you that there will be angle of prism. Now let's see firstly how much deviation net in general formula I want to prepare, and for that how what we can do. Let's see. because all the time I am not going to perform 2 times of refraction and then I will be writing the result. So I want in general things. It is already the diagram that I have explained you that is present here. So okay, just now we have to solve. Fine. Should we start? See, first step, I want a relation between A, R1 and R2. How I can find? Now let's understand. But if I will ask you, tell me this angle, what you will be saying? This is the normal. This angle is R1. If I will ask you this angle, how much you will be saying? Can I say it is nothing but 90 minus of R1? This angle that I have drawn there. Pakka? ये बताओ. What will be saying about this angle? Can I say same way? If this angle is R2, this is the normal. That means ये complete angle कितना हुआ? 90. 90 में से R2 हटा दो. What will be the remaining angle? This will be called as 90 minus of R2. इतना तो समझ में आता है. Correct ना? And now if I'll ask you, tell me what is the total sum of angles of a triangle. This is the triangle that is forming. Here it is a triangle that I am talking about, upside triangle. So I'll be writing what angle of prism is already there. 90 plus 90 minus of R1 plus 90 minus of R2 is equals to 180 degree. Correct. So now what I will be writing? I will write A minus of R1 minus of R2 plus of 180 is equals to 180. That means 180 will simply get cancel out. Then what I can write here, it will be equals to A is equals to R1 plus R2. This is the first important result that you have to remember for prism. Angle of prism is equals to angle R1 and R2, and now you are very much clear about what is R1 and what is R2. Correct. Now let's move further, because fine, at the end the net motto is what? To calculate the net deviation. Okay, so tell me what you will be writing about deviation 1. Deviation 1 you will be writing as I minus of R1, and deviation 2 here you will be writing it as E minus of R2. So if I have to, and both are in the same clockwise direction, both the deviations are coming in clockwise direction. I have told you by the diagram also. So net deviation, if someone will asking me, I will be telling them, I will write what? Deviation 1 plus deviation 2. Ab likho, what is deviation 1? I minus of R1 plus, what will be writing about deviation 2? E minus of R2. So यहाँ पे क्या लिखोगे? I plus E and take minus common R1 plus R2. Correct. और ये बताओ what you have learnt about R1 plus R2. Just अभी देखा है, R1 plus R2 can also be written as what? A. So the net formula of deviation, directly याद रखना, I plus E minus of A. For a prism, the formula that you have to remember for angle of deviation, net deviation is equals to I plus E minus of A. Minus of A. A means what? Angle of prism. सही है? Very good. So now just apply the formula here and let's see what is the result that is coming. Let's apply the formula. ये क्या आ गया? What are the formulas given, and तुम check करना from the conventional method also the answer is coming same or not. I know that I have already cross checked it. Now it's your homework to cross check it by the conventional method. Apply करना, यहाँ पे Snell's law, R1 calculate करना, R2 calculate करना, deviation 1 calculate करना, deviation 2 calculate करना, then check that okay the net deviation is coming or not. Now I am going to directly use the formula that we have studied, that is I plus E minus of A. What is I? 60. E. E is not given. That means again you have to calculate, because E is not given. If E would be have given, then easily you can find the answer. Anyways, we will calculate E also. E minus of, I will do what? 60. Okay, so net deviation is coming, that is equals to E only. So we should calculate E. Let's calculate. Firstly, tell me what will be R1. R1 कैसे लिखोगे? Root 3 is equals to 1 into sine of 60. Sine of 60 is equals to root under 3 by 2. R1 can be written as what? Sine of write it properly. Write it properly. Yeah. Right. 1 into sine of 60 is equals to root 3 into sine of R1. यहाँ से it will become how much? Root under 3 by 2, root 3 cancel, and R1 will be equals to 1 by 2. 1 by 2, that means R1 is equals to 30 degree. If R1 is equals to 30 degree and angle of prism is equal to 60, that means R2 is also equals to 30 degree. If R2 is equals to 30, can you calculate E? E can be written as, now right, root 3 into sine of 30 is equals to 1 into sine of E. Now 30, it will become 1 by 2, 1 by 2, that means it will become root 3 by 2, that means E is equals to 60 degree. E is equals to what? 60 degree. So how much you will be saying? I plus 60 minus of again 60, that means the net deviation is coming equals to 60 degree. Net deviation is coming equals to 60 degree. Clear? One more very important thing, if I will tell you, to be noticed, because after some time I am going to be in complete depth about that, because that is a fundamental, basic, most important requirement, is if I will exchange this I and E, is anything going to be changed? Is the net deviation is going to be changed? Yes or no? No. Because at the place, let's suppose I will be writing I को लिख दो E and E को लिख दो I. So again when you will be writing, E plus I minus of A. So can you say the net value is going to be same? है ना? Good thing na? Now why I am telling you, I will tell you after some time. Just wait for a moment. We will be understanding that also. Very interesting case. When we will be exchanging the value, actually it doesn't matter. Okay. See. Let's suppose now I have to plot a curve between angle of deviation and I. Okay, for a prism. So how I can find the relation? Let's see. Firstly, applying Snell's law, what I will be writing, right? Apply Snell's law on both the surfaces. Right here, what will be writing? N1, or directly if it is given as air, 1 into sine of I is equals to n times of sine of R1. N times of sine of R1. Fine. And then you will be writing what? At the second spot, if you have to write n into times of sine of R2 is equals to 1 into sine of E. 1 times of sine of E. So if you have to write what is E, how you will be writing? Sine of E can be written as, or directly if I will ask you, tell me how much E you will be writing. E can be written as, how much? E can be written as sine inverse of what? Of n times of sine of R2. N times of sine of R2. Anyways, this result will not be that much helpful for you, but still how it is written, I am just explaining you. E can be written as sine inverse n times of sine of R2. Now how you can write sine of R2 as well? Sine of R2, it can be written as, it can be further written as sine inverse n times of sine of R2 can be written as A minus of R1. How it can be written as A minus R1. Now how R1 can be written as? R1 can be written as sine inverse sine of I divided by n. So this much of big relation when you're putting up finally, how you write? What is the formula that I've told you? It is equals to I plus E minus of A. And the place of E, you can see this much of big relation when you'll be writing, then you will be getting finally some result. So directly we used to plot this, and anyways the plotting is not in your syllabus. So you just have to finally understand what is this curve is between deviation and angle of incidence. Some important, very important points that you have to understand from here. I will star mark those points. This kind of curve will be coming. This kind of curve will be plotted when you will be relating those quantities that I have told you in the last slide. Okay, but that is not of that much of importance. The importance is for what you have to understand some points. See, first thing that you have to understand, for any kind of angle of deviation, when you will draw a line, let's suppose this angle of deviation is for a moment 30 degree. So for that deviation, can you say you have two angle of incidence? Because this curve is for angle of incidence. So this is the first very important point that I am telling you. What is the first point? You always remember, you cannot forget these points. What is the first point, student? For any angle of incidence, you will always have two angles. For any deviation, you will always have two angle of incidence. First angle of incidence, that is always I. second angle of incidence will always be E. The moment just 2 minutes back I was telling you now that what will be happening is, does any change is coming if I am changing the angle of angle of incidence is equal to angle of emergence. If I will exchange I and E, is there any real change is also coming? No. So that's why I said that for any angle of incidence, two angle will be there, and two angles are what? I and E. This is the first thing. Second thing is, come to minimum deviation. Minimum deviation. This is a minimum deviation line. Now, what we'll observe at minimum deviation, what happened? Is it streaming properly or not? Or is there any lag? Is it streaming properly or not? Tell me in the comment section if it is clearly visible. I think so. It is should be clearly visible. Tell me once in the comment section if so that we can proceed further. Otherwise, if voice is not clear, then again I have to explain. Let me cross check it. I hope that this is going fine. Okay, should we start? So what is the second important point that I was telling you about is, the second point that I am telling you, at the minimum deviation, what will be happening? There is only one angle of incidence that you will be having. Why? What actually happened at this point? What actually happened? This I is equals to E. At this point, what will be happening? This I will be becomes equals to E. That means their angle of incidence will be equals to angle of emergence. This is the second important point that you have to understand. Next important point is for maximum deviation. When maximum deviation happens, always remember, for maximum deviation, this will be what? This will be I, and this will be what? E. The angle of emergence is always equals to 90 degree. This is fixed. Directly use this condition, calculate our maximum deviation. For maximum deviation, what I've told you, that this angle of emergence will be equals to pi by 2. That is equals to pi by 2. This much of important things, if you remember, you can easily calculate all the values that is required. Okay, you can easily calculate all the values that are required. Now this was the qualitative analysis that we had to do. Now let's go to the quantitative analysis, that how much the formulas are coming, what are the values that you can write. Okay, see, now for minimum deviation, what you can do, minimum deviation, if I will ask you what will be the formula, deviation formula is what? I plus E minus A. But for minimum deviation, what is the condition that you have created? You have said, sir, I is equals to E. You remember that curve that was telling you that I is equals to what? E. If I is equals to E, what will be saying here? It will become 2I minus of A, that is equals to minimum deviation. That is equals to minimum deviation. Okay. So one more very important why that is lagging? Is it clear now? One more very important thing that you have to understand is, apply Snell's law here. This is the first important thing. Okay, isko star mark kar lo. Second important thing that I had to tell you, apply Snell's law here. What will be writing? Sir, 1 into sine of I is equals to n times of sine of R1. First equation. Here apply Snell's law. What will be writing? N times of sine of R2 is equals to 1 times of sine of E. Sine of E. So if I am saying that it is the case of minimum deviation, what will be saying? I can simply say sine of I is equals to sine of E. I can simply say what? Sine of E, I is equals to sine of E. So I can say if these two are equal, I can simply, can't I say that sine of R1 is equal to sine of R2? Very much clear. So I can simply say if sine of R1 is equal to sine of R2, I can also say that R1 is equals to R2. So I can also say that A is equals to R1 plus R2. So it will be nothing but equals to R plus R, and A can be written as R can be written as A by 2. So I will say remember this one. This is the first important things, and from there we can generate a general formula that it's up to you. I'm leaving up to you. NEET students, remember it. JEE students, don't remember it. I don't think so that it is that much important to remember that result. Okay. Fine. See, what I was telling you, what about this refractive index? If it is a case of minimum deviation, you can directly write the formula of refractive index. How you will be writing? Let's see. What you'll be doing, you'll apply the formula and writing the Snell's law, n1 sine of I is equals to n2 sine of R, correct? And can I say you will be writing this n is equals to nothing but sine of I divided by sine of R1, sine of R1. So how you can write I also? See from here, can I say you can write I is equals to, from this equation, I can be written as minimum deviation plus of A divided by 2. So bus and then apply sign on there. So sine of I can be written as minimum deviation plus of A divided by 2 divided by sine of R1 can be written as A by 2. So this is the direct formula that is written here. It's up to your choice. If you want to remember, or directly you can calculate it also. There is not that much of time will be required in the exam. But specifically if I'm talking about JEE exam, then you can derive it also, then no problem. So just apply the same formula here also, and let's see what is the case that is coming. Apply the formula. What is the value of n that you are having? N is equals to sine of A, that is 60 degree, plus minimum deviation. Minimum deviation is given as 30 divided by 2 divided by sine of A by 2. I don't remember this much values because I never a big fan of remembering the values. Better you are understanding the concepts. Here it will become how much? Sine of 90 divided by 2, that means sine of 45 degree divided by sine of 30 degree. 45 will be what? 1 by root 2. 30 will be what? 2. That means cut. It will become root 2. N value will become root 2, and same kind of term will be like required when you are going by the natural method. क्या करोगे? कुछ nothing you have to do. Just apply the formula. You will have angle of incidence. Once you got angle of incidence, all the values that you will be getting. Lesser size as compared to this. That means angle of prism will be nearly equals to 3 degree, 4 degree, 5 degree. This much of angles you will be watching here. Okay. This much of small angles you will be getting. So due to angle of, if angle of prism will be decreasing, due to that what will be happening? Angle of incidence will be decreasing, R1 will be decreasing, R2 will be decreasing. All the angles now will become very small. Due to the one decrease, all the angles will be very small. So what will be happening? Or when all the angles will become very small, due to that, if you will be applying all the formulas, what will be saying for A? A is equals to what? R1 plus R2. This is one result. Okay. Now apply. This is the thin prism. This is the natural prism. This is the thin prism. लिखो natural prism में क्या होता है? What is the Snell's law? You will apply on the surface 1. This is surface 1. This is surface 2. What is the Snell's law? You will be writing 1 time of sine of I is equals to n time of sine of R1. Then what will be writing? And can I say all the angles are very small? If theta is very small, what I can write? Theta is equals to tan of theta is equals to sine of theta. So sine of theta can be directly written as theta. क्या लिखोगे यहाँ? I is equals to n times of R1. This is one thing that you can write. Then write the Snell's law at the second surface. At the second surface, कैसे लिखोगे? N times of sine of R2 is equals to 1 time of sine of E. And again I will say what? That these angles are very small. These angles are very small. That means you will write what? N into R2 is equals to E. N into R2 is equals to E. And net deviation, if I will ask you net deviation, what you always write, students? I plus E minus of A. But for thin prism, what is the direct formula that you have to remember? Basically, this for one single important formula, I am deriving all these things. I will be written as what? I from the first equation you can write nR1 plus E can be written as nR2 minus of A is equals to, here what you can do, take this common, n R1 plus R2 minus of A. हर जगह नहीं बचा यार. Write it here. I'm writing it here. So now What is R1 plus R2? R1 plus R2 is nothing but A. So this result will be looking like Na minus of A. This is the formula for deviation of thin prism. So finally, what you can write the deviation? Take A common, A n minus 1. This is the deviation for thin prism. Deviation for what? Thin prism. Very famous result, A n minus 1. Lot of places it is used. Very important result also. A times of n minus 1. Clear? So let's apply this formula and now let's finish this. Refractive index is 1.5. Deviation, directly I know the formula, that is equals to n minus 1, A n minus 1. A is equals to 4 degree, n is 1.5 minus 1, means 4 into 0.5 half, that is equals to 2 degree of deviation that will be coming for a thin prism. Why we said that it was a thin prism? That because angle of prism was equals to 4 degree, very very small. Is it clear? Is it clear? So this was all about this lecture. Until next time, keep learning, keep growing with Tapasya, Endigu, and then Digu, Namma Tapasya.